Hello everybody, I'm George Takahashi. I'm the lead visualization scientist of the Envision Center, and I'm here today to talk about the XR Classroom Initiative. All right, so the Envision Center, for those of you who are not aware of us, we are a data visualization, VR training, simulation, and multimedia creation laboratory. And we're located down in the basement of the Stewart Center, sort of in between the walkway of the PMU and the STU basement. So if you've kind of been by and see all the flashy lights and it's really cool, that's our laboratory. We're located where the old pool hall used to be. So if you're kind of an old timer or happen to know where those used to be, that's where we're located. So to kind of tell you a little bit more about what we do and what we've accomplished over the past few years, we essentially have been tackling the challenges of visualizing complex three-dimensional data sets, as well as providing a medium for interacting with the virtual environments, mostly to train techniques or physical manipulation of digital environments. And here's some of the examples that I presented earlier today. Starting with, on the left, the ability to look at and explore three-dimensional data sets in an intuitive fashion. I sort of explained the challenge here where if we wanted to represent something that is three-dimensional in nature, having the opportunity to actually touch it or manipulate it, just like if we're holding something physical, is a lot more intuitive than trying to look at an abstract 2D representation of it. We also have been leveraging VR for being able to provide that physical manipulation. So if you wanted to be able to teach somebody how to utilize a Geiger counter, being able to have a virtual version of this can be a lot more intuitive than watching a video of somebody performing this action, or even worse, if you have just a lecture of something. Being able to actually manipulate that or have the physical technique is a lot more conducive to that learning, as well as being able to immerse people inside of a 3D full environments if you want to provide like scenarios or have the opportunity to kind of experience it. Being able to create a digital version of that can essentially allow them to kind of smoothly transition the learning experiences from a classroom environment into the physical world. So these are some of the challenges that VR has and our XR in general has enabled us to solve these problems. And these can be kind of broken down into sort of these three facets. I've been calling this sort of the triad of XR, but it is essentially broken down into those three particular components that I gave examples of earlier, which is visualization, interaction, and immersion. Now, it just so happens that the way I represented this, it looks like a cube, so I figure how better than to represent the analogy of looking at three-dimensional data than providing it in a 2D graphic. So, okay, now as XR has allowed us to explore and solve a lot of these challenges, we started to encounter some additional problems. Even though as a technology it is very budding, it's growing, it's something that you can go out to a local Best Buy and get equipment, we're still encountering some difficulties when we want to scale this up to a much larger group. So if we want to put this inside of a classroom environment or have multiple people leverage this beyond just a research project, we started encountering some interesting challenges here. Now, currently the Envision Center has 13 active XR projects, and these are spanning not just in STEM, but across agriculture, education, or engineering, liberal arts, pharmacy, and science. So it is definitely a very broad tool that can be utilized. From just my count, there's over 10 plus departments that actively utilize XR technologies in their curriculum, both for research as well as classroom usage. And with the start of the 2023 Innovation Hub VR and AR grant, we anticipate that the demand for these kind of technologies are only growing. So with these growing pains, we have to think about how do we leverage XR effectively as a tool, and what do the spaces need? So as we've started to look at some of these other departments that have created their own laboratory, or faculty that have just gone out and bought their own devices, we start realizing that they need some level of support, some structure, training for the increased demand, some guidances on those best practices, as well as how to overcome some of the barriers that come with utilizing XR as a technology. So for any of you who have utilized VR in the past and have seen videos of people running into things or having trouble utilizing these devices, these barriers to entry crosses over into the classroom environment and are further amplified when you think about it from an accessibility perspective. So if I want to have a scaled up laboratory of 30 plus students all leveraging this device, you start having to worry about what is the economy of scale here. Do you have cost issues, space constraints? Do we have to worry about issues with ergonomics? Are people going to have to tailor their device to fit their particular glasses? Do they have a vision impairment or accessibility concerns that need to be considered for this? What is the long-term sustainability of using these devices? Especially when you think about XR as a growing technology, you can see that there's almost a new VR device or a new cool toy that comes out almost every 2 to 3 years. So what does the iteration of this or the replacement of these technologies look like? And then first and foremost, what does safety look like? If somebody is putting on a headset and walking around inside of a room or giving a presentation like this, you can imagine if I can't see the real world, the opportunities of me falling over start increasing pretty drastically. So considering this inside of a classroom environment and being able to provide this for educational purposes, we have to think a little bit about what are these other considerations that transform that classroom environment. So with that, we are launching the XR Classroom Initiative, essentially a series of guidelines, resources, support platforms, as well as an actual classroom itself to be able to essentially help promote the leveraging of these spaces with the close to 20 years of experience that we've gained within the Envision Center to provide this as a service. In my earlier presentation, I talked a little bit about our past projects and what we've done so far in leveraging these technologies, but they've really kind of fit more as a research opportunity rather than a full mass-scale deployment. It's only within the last 5 years or so where we started to be able to take these technologies to a sort of a critical mass where we can deploy these into classrooms and actually fully leverage them as an educational opportunity or beyond a research tool. So with this, we're trying to essentially categorize our interactions in one of three different ways. One of them, deploying content for class use. A lot of the rich materials that are out there make it so much easier to essentially take existing applications and just putting them inside of classroom environments. If you can think of like YouTube 360 videos or virtual tours that you can get of real estate experiences, or if you want to actually take somebody to a existing like 360 experience that's been generated in full 3D. Those are apps that already exist today that people can leverage. But if they need the structure or the equipment or the know-how to be able to have this, this is something that we can provide. If they need to modify existing infrastructure or existing apps to be able to suit their needs, maybe they need to use a platform like Engage VR or Mozilla Hubs to be able to tailor it to their particular instructional content, they can work with groups like us as well as a lot of the students that we train up to be able to perform these to essentially accomplish their needs. And then finally, the creation of new solutions. So this would be kind of similar to the applications I showed previously, being able to build up content from the ground up to essentially provide those educational materials. So within inside of our Envision Center, we currently have 20 or so VR plus or VR/XR headsets. But with the release of the new Quest 3 headsets coming out here within the next quarter, we're likely going to be looking at an additional 40 headsets to be able to have a much larger classroom environment. Along with this is going to be tiled inside of our Forge XR Theater, so we can essentially combine that with our tiled display system. So this is an 8K massive monitor that we can use as our control or command center, tied as well with the motion capture system that allows us to do additional ergonomic studies on top of this. So if you want to see how people are moving or how they're interacting with each other inside of that virtual environment, you can not only get their virtual avatar information with the controllers, but you can also get the full body analysis on top of this as well. And then tied into this XR classroom is our XR consortium. My apologies for missing that slide. So the XR consortium is essentially going to be an iteration of a previous VR consortium that we had built essentially as a user group or community-led platform to essentially help faculty, staff, laboratories, and students to essentially connect to each other in order to be able to share resources as well as provide best practices or essentially look for collaboration opportunities. We're going to be tailoring this to the people here at Purdue through a biannual seminar as well as a forum to essentially highlight the types of things that are happening here at Purdue, as well as look for additional opportunities for collaboration through industry partnerships as well as grant sponsorships. Right. If you're interested in learning a little bit more about what we're doing with the XR Classroom, I do encourage you to visit us at the Envision Center. I use the saying, a picture is worth 1,000 words. Well, if you can actually put on a headset or explore some of these things and provide an image around this, that's going to be worth a lot more. So definitely come and check us out. And thank you very much. Right. Do we have any questions? How would I avoid? So this is actually where a lot of those technologies become very powerful, especially when you're starting to combine AR, where you can just add digital content superimposed into virtual environments. So instead of fully blocking off the physical world and allowing you to essentially forget that there's a table here or a giant precipice down in front of you, by superimposing that important data on top of it, you can essentially avoid some of those problems. Funny story that I used to mention is, our place used to be the old pool hall, so we actually had a virtual pool table at one point to be able to essentially allow people to remember the good old days of having the tables there. However, one of the very funny challenges that we found is a lot of people want to lean on these virtual pool tables that aren't actually there. So we've had a handful of mishaps, mostly me, but yeah, if you try to lean over on a pool table that's not actually there, then just like falling off a stadium, you might encounter some learning opportunities, we'll call it that. So yes, as a part of looking at some of these new devices, going from the early usage of devices like the Google Cardboard, which are very low-cost, effective ways of getting a VR platform inside of a classroom, a lot of the headsets that are coming out nowadays are starting to blur the boundaries in between VR and AR so that you can have a very powerful system that can accommodate some of those challenges by merging both the physical world and the virtual world. Yeah. Great question. Any other questions? All right, thank you very much.